Okay, so let's dive into concrete mix specification. So there's two parts to this discussion. One is what do we spec as the engineer of record? And then two, what does the batch plant give us that we review and approve? So this first part we'll get into what we spec, and then I'll go through an actual mix design and a document that gives some great guidance on how to review things. So the first thing that we need to do is understand what the strength minimum. So one of them is from the code, which says for certain types of elements, we need a minimum strength. The other part of that is what did we design for? So generally early in the project, we'll establish these values in the general structural notes and base them both on our design choices and these. So whatever we do, we need to meet these, but often we go heavier or higher. So like special moment frames, rarely would we go below 5,000 in a design office, but the code specs a minimum. So in my general notes, I have kind of a starting point for compressive strength where I have certain minimums that I'll use, and then I'll edit this to the specific project. And then I have additional information here that I'll specify, and we'll get into more of how we get there. Okay, so strength requirements. We're going to specify F prime C, and then the mix designer will design for F prime sub CR. So they'll aim for a 34% higher value. And I would say it's pretty rare in my experience that the concrete comes out weak on a project. And that's for two reasons. One is extremely expensive to tear things out and replace them. So the batch plants are really motivated to get their mix right. And two, a lot of the batch plants are sophisticated enough that they have things dialed in really well. So one of the changes in the last 10 years or so in the code was including these exposure categories and classes based on what's going on. And so as a designer, we need to go through, or a specifier, we need to go through and determine each of these four classes, what we have going on. And this is something that as a new engineer, you might not do completely on your own. Or you could, just depending on what's going on in your office. So basically, you can step through, choose which of these classes make sense. This sulfate is something you'll get from the geotech report. They'll test the soil and determine the amount of sulfates. This is something that's pretty easy to get, as is this. If we go back to that mix or my general notes here, I'll specify those exposure classes, and you can see as I go from normal to a high chloride, which would be like at a potash mine is where I've used these, things bump up a little bit. Okay, so continuing on, once we've established those, then they're tied to different requirements. So if I have different F classes, it'll give me requirements on water cement ratio minimums, or maximums rather, minimum compressive strengths, and then some information on air content. So entrained air, which is microscopic air, not like big voids, gives the concrete the ability to move under thermal loads. For different S, so sulfate exposures, it's going to give us water cement requirements, compressive strengths, different cement types. So here would be cement type 5, which is sulfate resistance. And then we have different requirements on the cementitious materials. So basically, we start here, we select these values for in each class or category. Then we come here and we pick out what the requirements are. And so it's probably redundant to show um, oops, both this information and all of these things. But for now I do, and maybe at some point I'll stop that. All right, similar thing for the W and C exposures. So basically you use the worst case of all of these, put them into a spec or a general note sheet, and that's your thing right there. Different aggregates. We basically want a mix of aggregate that at the end of the day packs pretty uniformly. So we'll have some fine aggregates and then some larger aggregates. And when those are all mixed together, you get something that the cement has less. It's good to minimize the cement volume usually. Then there's less shrinkage, less cracking, and whatnot. All right, cement types. Typical is one, which usually is dual qualified as 1 and 2. There's a high early, so this is good cold water or cold weather. There's a low heat of hydration, which in large pores or in the summer can be valuable, and then high sulfate. I would say a lot of times now these high early and or retarded hydration is done a lot of times through admixtures. Different types of cement. Fly ash is very common. Silica fume is less common but can have some value. And then blast slag. So these are usually waste products either in the power generation or the smelting industries. Alkali silica reactivity can be a problem. This is where the cement, the alkaline cement and the silica react. It can cause cracking, and this can get bad enough that the entire structure needs to be scrapped. So that's something we need to check in our mix design. Sulfate attack, you can see there was high sulfates in this mill, and it just basically ate the cement, which then exposes the aggregate, and over time will just eat away the whole pier. Chlorides penetrate through the concrete and corrode the rebar, and then as the corrosion product expands, it pushes the cover off, and it's just kind of a cycle of expansion, more chloride attack, and more corrosion. Okay, so that's the first half. The second half is getting a mix design and actually knowing what to do with it. When I started my career, I was handed either shop drawings or mix designs and said, hey, check this, and really had no idea what to do. So I've given you guys this guideline from Structural Engineers Association of Northern California, which is a great document about how to review a mix design. So like on this page, it'll basically step through different things that they suggest you check. You can come to this example and see where those might be. Here's data or notes and thoughts on test records, and you can come here and basically see, okay, this is how I would get into this. I've also given you an actual mix design from a project, which basically this is something that you would review as an engineer, and maybe you can take that review guide against this document and see if you think it's adequate. So back to the PowerPoint, the basic things we want to check are, is the compressive strength correct? Is the slump, water, cement, durability related items, are they there? Cement type, admixtures, density, proportions. So that's kind of what we specified, is it in the mix design? And so basically we would take our general notes, compare them to what got submitted, and then work through, do they line up? The second major part is, do we have test data? The code requires that we have a certain amount of data that shows that that mix design actually worked. And so you can come here to our design that we have as an example, and you can see, okay, for this sample, this date, the 7-day break was at 3,700 pounds, 28-day at 5,000. So if this is a 4,000 PSI mix, which it is, hitting 28 days at 5,000 is nice, but you can see here, this one came in at 4,000, that one at 6. So basically you just go through this data and make sure it looks legitimate, look at the date range. The code wants 12 months of data in recent 12 months. If the batch plant doesn't have this, then there's some other ways that they can provide the data from a trial mix, where they basically make a mix, test it, and then show you that data to prove that their mix will come up. Something else that this will have are the gradations of the aggregate. So you can see the fine aggregates are down in here, and the big aggregates are up here. And then something that's important are test data for the different cements. So here's a cement report from Wholesome. So that's the Devil Slide plant up near Morgan, Utah. And this is fly ash, so wherever this came from, let's see, does it tell us? Anyway, we can figure that out. Here's an admixture, so this is air training admixture. So this is like a little liquid that they put into the concrete. It creates microscopic bubbles and gives more durable cement or concrete mix. All right, so with that said, again, two parts. What we specify as the engineer to tell the contractor and the batch plant what we want, and then reviewing the mix design to make sure that what the contractor is specifying or proposing will actually work for our application. And as a note, this is a document put together by building engineers. If you go to a DOT, they have an even more exhaustive checklist on how to check a mix design. And you basically just grind your way through it, but be thorough and thoughtful about it. And sometimes you need to reject the mix design because it doesn't meet the requirements. And in that case, you ask the batch plant to go back and provide what you've asked for. All right, we will talk more about this during class.